Hello everyone! In this video, I'll take you through the incredible journey of how stars are born, live, and die, and how we can actually plot their lives on something called the Hertzsprung-Russell diagram or the HR diagram. If you've ever looked up at the stars and wondered what stage of life they are in, this is the perfect guide. Stars are born inside massive clouds of gas and dust called nebula. Gravity pulls the gas together, forming a dense, hot core. The core becomes a protostar, a baby star still gathering material from its surroundings. Think of it like a star embryo, slowly growing until it's ready to shine. Once the protostar gets hot enough, nuclear fusion kicks in, so hydrogen atoms fuse into helium, releasing energy. This marks the start of the main sequence stage, where stars spend most of their lives. The Sun, for example, is currently in this phase. It's been stable for about 4.6 billion years and will stay this way for several billions more. What happens next depends on the star's mass. For stars like the Sun, they expand into red giants, then shed their outer layers and end up as the white dwarfs. But massive stars, they become supergiants, and when they run out of fuel, they explode in a supernova. That supernova might leave behind a neutron star. A neutron star is an incredibly dense core, or even a black hole. A black hole if the original star was massive enough. So when you see a twinkling red star like Betelgeuse, you are actually seeing a supergiant that may explode sometime in the next million years. It's in a race against time. The Hertzsprung-Russell diagram is like a stellar map. The x-axis shows temperature in Kelvin decreasing from left to right. The y-axis shows luminosity, how bright a star is going up the graph. Stars don't just fall randomly in this diagram. They form clear regions based on their temperature and brightness. So there are three key areas. The main sequence cuts diagonally across the graph. This is where most stars live, including the Sun. The upper right is where you find giants and supergiants. They are bright but cooler. So the lower left is for white dwarfs, so hot but faint stars. Stars are like humans. They have similarities and differences with each other, but all have a finite lifetime. The Hertzsprung-Russell diagram, which is known as the HR diagram, is one of the most important tools in the study of stellar evaluation. It plots the temperature of the stars against their luminosity. Depending on its initial mass, every star goes through specific evolutionary stages dictated by its internal structure and how it produces energy. Each of these stages corresponds to a change in the temperature and luminosity of the star, which can be seen to move in the different regions of HR diagram as it evolves. This reveals the true power of HR diagram. Astronomers can know a star's internal structure evolutionary stage simply by determining its position in the diagram. The HR diagram helps us visually understand a star's temperatures, brightness, and stage in its life. It's like a biography of a star, written in light and heat. So I hope this helped you understand both the life cycle of a star and how we use the HR diagram to trace it. The stars above us are at different stages of life, some just starting and others nearing a dramatic end. Thank you for watching.